In this section, we are going to have some applications from geometry. In example 1, we're asked to write a polynomial that represents the area of the square shown here. And there's a couple of ways to do this. We're going to go through both of the methods. The first is to find the area of each individual piece inside and then add them up. So we're going to start by finding the area of region A. So area of region A. And if you look at region A, that's this piece right here. It has length x and width x. So the area is going to be length times width, or x times x. Writing that as an exponent, that's x squared. And we're going to do the same for the other pieces. So the area of region B, if you look at this, region B is the same size as region C. So I'm just going to do those together. So the area of regions B and C both have length x and width y. So x times y gives us x, y. The last piece here, D, the big square down on the right, has, let me just write down area of D. The length is y, the width is y. Multiplying those together, we have y squared. So to find the total area, all we need to do is add up the areas of all those pieces. So the total area is going to be the area of A plus the area of B plus the area of C plus the area of D. The area of A was x squared plus the area of B was xy plus the area of C was xy plus, and the area of D was y squared. Now we just need to see if there are any like terms. Here we have xy and xy. So x squared plus, combining those like terms, 2xy plus y squared gives us the area of this figure. Now another way to do this, notice this is the same figure here. Another way to go about this is to just find the total area of the square. So if you look at this length, the total length there is x plus y. Same with the width. Here, down here, the total width is x plus y. So to find the total area of the entire figure, it's going to be this length, so x plus y times the width. So times x plus y. Multiplying these together, we have x times x is x squared. X times y is xy. Now do the same here. Y times x gives us yx. Y times y is y squared. Now looking through this, we have x squared. xy and yx are like terms. They're written in different order, but you have the same variables raised to the same power. So they are like terms. You can still combine them. So plus 2, and I'm just going to put the x first, xy, and then plus, there's our y squared. That gives us the total area. And now I want you guys to notice this answer is the same as the one we got before. So two different ways of doing the exact same thing. Now here in example 2, we have a different figure. It looks kind of like a window. We're asked to write a polynomial in simplest form that represents the area of the shaded region. So we want just this part, just this dark shaded region right here. So our strategy is going to be finding the total area of this big square and then subtracting off all the little squares. So we need to find first the area of the big square. All right, the length is y, the width is y, length times width, y times y gives us y squared. Then we need to find the area of all of these little squares. If you notice, the dimensions are the same, so we really only need to do the calculation once. So each little square has area, length of all of them is x times x, which is x squared. So now we just need to find the area of only the shaded region. So to find the area of the shaded region, essentially we're going to take the area of this big square and subtract off all 4 of these little squares. That'll give us the shaded area. So the area of the big square, that was y squared minus, and each little square has area x squared. So minus x squared, minus x squared, minus x squared, minus x squared. Now combining like terms, we have y squared minus 4x squared.